Hello friends, greetings. Welcome to How to VLAN channel. This is DB VLAN stream. Today in this video, we are going to see the interaction of our universal connection pool on Oracle database. This is very important for an Oracle DBA or any DBA, for instance, how a connection pool works against a database. This is going to be an understanding video, and also we will really see them in action in the database. So it's kind of a understanding plus exercise video to see if our understanding is correct in terms of observing the actual effect of the connection pool. So we are going to see live code example and also live execution of the code and see how they reflect in the Oracle database and how they manage the connection efficiently. Okay, so let's get, as usual, as we get started, we draft our steps, right? So we go through our steps. First is the reference URLs for this particular exercise. One is this Oracle's public repo where you get all the kind of codes that you want for testing the connection pool, universal connection pool, for instance, using the JDBC thin client and diagnosability in JDBC. So in case if you face issues with connection pools or any sort of any issues in the connection pool which is established using the JDBC, you will need this diagnosability in the JDBC. So that's available here. And understand what is connection pool and why it is needed. So in, for example, I'm talking about Oracle database, but it may apply to all the types of databases, other databases as well. In Oracle, we have three types of connection. One, dedicated, where you have one client process, one server process. So all the requests coming from the client is handled by one server. So consider you're going to a hotel, you get an you get a dedicated person who serves you. That's what is called this dedicated server process and dedicated method of connection. And you will see this in TNS entry where connection type equal to dedicated. And the second is shared, where you have many uh, clients, but there will be one or few server process. This is called shared servers. The parameter name in Oracle is indicated by shared underscore servers. And in TNS entry also you will mention connection type equal to shared. When you mention connection type equal to shared in TNS entry, only if there is a shared server started in the database server, your connection will succeed. Otherwise it will fail. And you can see this dispatcher coming into action when you see the shared server process. Dispatcher is critical. I'm calling out only a critical background process, but there are many other processes participate in this shared server. And third one is pooled connection. So this is where Oracle allows you to connect to a Oracle's own DRCP, which is called a database resident connection pool. Oracle creates a connection pool on its own for PHP applications, but it is not limiting to only PHP. You can use it for any sort of you can actually use this to replace your dedicated connection itself. Say for instance, 10 clients connects to the database using SQL Plus. You can still use the DRCP. Just you need to update the TNS entry saying pooled, but only if you start the DRCP, the pooled connection will succeed. And here CMAN is one of the critical process, and you will see this dispatcher and CMAN process visible in the listener also. I think it will be shown as N something, N triple X something like that in the listener background process. But we are not going to see how this connection type is going to work, and I'm not going to go in deep about how each of this connection type works. That this is not the video for it. Maybe I'll record a video on this separately. So this is are the various types of connection, and we are going to look at the pooled connection. When I say pooled, this is not database resident connection pool, but it's a universal connection pool used by Java and the JDBC based applications. Here our condition is JDBC because it's most prevalently used by most of the web application. So when the end user, say for instance it's a banking website, when let's consider you are trying to log into your personal account, you will not normally access the database directly. You will log into the web application and you will use the background service. For instance, the developers know there are two types of developers, right? Front end and back end. So the back end developers create a service and give to the front end users, front end engineers, and the front end people actually honors, use that background service to connect to the database and do the necessary operation for the end user or the client. For instance, in your case, consider you are actually trying to check the balance of your bank account. So you're logging into your bank, say ABC bank, and then you go to your check balance, and that is a service. In the backend, that particular service call will connect to the database and get the results for you and return back to your front end application. Consider here what does the service does. The service is a Java program, and the Java program will have the necessary SQL bound within it, and it will be connecting to the database using a JDBC driver. So to connect to a database, you need some sort of driver. Be it SQL Plus is a native client for Oracle. You can use SQL Plus also, but SQL Plus is very heavy. For Java, they need a very thin client, which is why it's called a JDBC thin client. That the name itself is. So that sort of drivers will allow you to connect. Say, and then the other type of driver you know about, it is ODBC, which is uh, the open source database connectivity product. So they are also available. So you can use ODBC or JDBC based on your application. But in here, it's a Java application. The natural choice is JDBC. So you'll connect to the JDBC. Say for instance, if you want to talk from one database to the other database using a DB link or something, then the ODBC will come into play. Okay. So here we are not going to deep into these types of drivers, but here you have a website and a service call, which is a Java program. Consider, and the Java program in turn calls JDBC connection to Oracle DB, and the call is returned in the reverse, and the end user will see the results on his website. This is what happens. Consider, uh, for instance, in India, you have State Bank of India. How many users are using it? The count is in 100 millions, right? So in case if so many users are connecting to the database, how huge this Oracle database to be needed to be in the background? You cannot imagine, right? The number of processes that you will establish is very huge. So this is when the Java program will use this universal connection pool. Here in the middle, there is one entity called UCP. This is a Java program, and this is universal connection pool. This universal connection pool have established 100,000 connections. Assume this 100,000 connection has lot of settings within it: inactive timeout and abandoned connection timeout. Inactive timeout, there are two types of inactive timeout. So and then length of the process. So for there are many such connection timeouts. Say for instance, you logged into your banking website. You didn't make any operation, but you just kept your banking website alive, and you kept your balance check operation alive. You checked it and then you left it, but you didn't do any transaction later. You just left it there. You're holding a connection here. So how long can I leave your connection idle like that? If you say consider an SBA or some other website, you may be lasting for 1 minute or 5 minutes maximum, and then after which your connection will be terminated, saying connection timed out. Please log in again. That's the timeout we're talking about here. So that will terminate your connection to the website login itself, because you need to get authenticated. Then you're establishing a connection. So somewhere a process is, you're holding a process that will be timed out in order to reclaim the resource you were occupying, but you're not making any operation or transaction. This is how overall flow it happens. So the same way you are logging into the website and making not doing anything and you're timing out, right? Similarly, for each of the service call you're making, there will be a timeout. You can declare a timeout. All right. So this is flow, and this is why we are using universal connection pool. You may understood now. Can I create 100 million connections? The server will die if you create so many processes. So instead, you will use a pooled connection. In the pooled connection, you will pick up an available connection. You are borrowing a connection and you're returning the borrowed connection back to the pool. That way, many people can use the same set of dedicated server process. Here, this is what is more important. It's not a shared server, it is a dedicated server. It will exactly behave like a dedicated connection, but just that you have a fixed set of dedicated process available for you, and a connection manager will manage the connections from you. Okay. Now, what should I do to the step number 2 is Download and edit needed UCP sample file from Oracle public repo in GitHub. Okay, here is one thing. It's not just the UCP sample file. We have to do one more thing. You need to do one more thing, which is you need to download this OJDBC 8.jar and universal connection pool.jar. So I'll keep this link also in our notepad. So download necessary JDBC jar and UCP jar, and you will need on top Java JDK 8 plus. Okay, for this test routine, and JDK 8 plus by default will be available on 19C, and we are going to conduct this test on 19C. See, I'm looking at Oracle 19C 22 and the compatible universal connection pool jar file and OJDBC 8.jar file. So this is very important. Okay, this is also you need. So download them. Anyway, I'll keep the copy of whatever jar file I'm using for this test routine in my Git repo. So you see, that's the next step. So prepare a SQL statement to be used in Oracle DB to access the pool statistics. You can see the below code can be downloaded from GitHub. So this is my GitHub URL, and you can see this code. I'm going to anyway post it in my blog, but you will see the code really available to download directly from my GitHub repo. And this jar files will also be there. So it's a um, so whatever code you need and whatever binary you need to execute, all of them will be available in a single place. Next, what is the test that I'm going to do? So this is where you have this Java program that you downloaded from Oracle site, public repo, UCP timeouts.js or Java, JavaScript, anything. Java only I kept. Okay, so you can see here they're conducting 4 test routine. One is demo connection timeout, wait timeout, inactive connection timeout, time to leave connection timeout, abandoned connection timeout. The first test routine is about testing availability of a process for the end user. Say for instance, the limit is only 100 users to log into the banking website. You are the 101th person. What will happen to you is what we are going to see. You will wait until what time? You will wait for 120 seconds, 2 minutes, something like that. Say in IRCTC you get service unavailable error, right? That is exactly what it is. And the service unavailable error you will not get immediately. You'll get after a timeout. The website will try to allow you to log in, but it will take time. It will take time, a time value that is set by the developers. They might have set it to 120 seconds, 60 seconds, or whatever it is. And then you'll get a service unavailable error because you really do not have a process to service you. So that's exactly what it is. The first test is. Second is demo inactive connection timeout. This. So I haven't explained you about how this will look like, right? This is how a JDBC universal connection pool works. In Oracle database, you have a process count. This is the upper limit of all the resources. Okay, this process count, this $e parameter dot process. That's the upper limit of all the resources. In turn, you will allocate. CPU is one other, but this is one other. Okay, this determines the number of processes that can connect to the database. From here, the session count is derived, transaction counts are derived, but this is the upper limit. Okay, you don't change the sessions or transaction in your parameter file. You will change only the process. Okay, others are derived parameters. So this is determines how many processes you can really connect to the database. Consider again our SBA website. Let's say you have 200, so 100,000 users, 100 process we have in the database upper limit, which means your connection pool cannot exceed 100,000. How many I can? Then you need a give resource space for the Oracle system processes, and then you have to determine about your application and other applications. How many other application you're running? Based on that, you will allocate a slot. Say you will say 50,000 connections I need to allocate to connection pool. Well, go ahead. That's a connection pool. When you start it, all the connections will become available. So you have 50,000 connections available for the end users to connect. Imagine when you make a connection in IRCTC during the Taka, this number is never, never actually never actually is enough. So 50,000 or 1 million, you will never be able to connect to IRCTC during that time. I used to hear announcements saying that we will ensure during Tatkal, anyone tries to book a ticket, we will ensure we get a ticket. But uh, it's quite impossible, right? To achieve that value, it needs to be a very, very fine-tuned system. You need to tune it from every stack. All right. But anyway, I appreciate how the amount of work the IRCTC has done. But I'm calling out IRCTC as an example here. Okay. So all the connections will become available here. 50,000 connections. Next, an application demand. So you're trying to book a retail. So you're logging in. Then you're borrowing a connection from one of the available connections. So then it becomes a borrowed connection. And the borrowed connection stays alive. Say for instance you connected to IRCTC, but you're not making anything. You're holding your own process. I will kill you after 5 minutes. This is what the developer would have said. 5 minutes after which your session will be terminated and the connection will be made available back to pool, which is it become an available connection. So other user can pick it up. All right. So when I say 50,000 here, there is again actually two types of connection. One is min pool size and max pool size. The connection pool will always ensure I give minimum connection pool allocated, and the maximum connection pool size is the maximum value that I can go up to. So the min pool size is always a lower number. Say 50,000 means you will say 10% of it. So 5,000. So the 5,000 will always be available. And from the 5,000 you borrowed a connection. For instance, if 5,000 connections are busy, the 5,000 first connection will be again established by the connection pool. It will be started again and it becomes a borrowed connection directly. But you will have some additional available connection because the universal connection pool will not start only the connection you are starting. It has some allocation size. Say in batches only it will do 5, 10, 20, something like that. So when you ask one connection, it will allocate 5 connections. Alright, because the connection starting and destroying is a very, very costly operation in the OS or in the any database or anywhere. Cost start of the connection because you have a lot of code path to execute in order to create a connection. You have authentication and you have a process creation. There are many things in the code path. You have a memory allocation. There are many things. So, and then that same when you destroy a connection, you need to release the code. You need to release your connection, release all the resources you allocated. So many executions are there. Even if it is a millisecond, imagine for 100,000 users, how will I manage it? That's when this connection pool avoids all those resource consumptions and time wastages. Okay. So now you get a borrowed connection and there are two control parameters here. We are testing only two, but there are many control settings you have. Okay. Demo the time to live connection, which is what it means. Time to live. This determines the length of your connection. Say for instance, this determines how long I can retain a connection. The borrowed connection itself. You may be doing a transaction through halfway through your transaction also I can kill your connection if you're taking more than the time that you are allocated. Second is abandoned connection timer. Say for instance you left your machine idle. You connected to the booking website or banking website and you don't make any transaction. You're leaving your connection as such idle. You'll just lock your machine and go away. Or you open your web app in your mobile and then you didn't do anything. You just go to the other application and you enjoy watching my YouTube video for example. So what happens is the other session is still idle and what happens to it? It's a waste of resources for everyone. So we kill that again. What happens to the such killed session? It will become an available connection for others to use it. And again, there is one more timeout. Say for instance, um, my minimum connection is only 5,000, but I have allocated 10,000 connections. The rest of the 5,000 connections are still in the available pool, but they will not survive forever. There is one more timeout which is called inactive timeout. Inactive connection timeout. After that inactive connection timeout, when I say they don't make any transaction, they are still alive. They are not used by any process incoming. They will be terminated and released back to the database process count as a free process. So anyone else can use it. So it is a shared area everyone is using. And your application alone is interacting with the shared area like this. So, but there are other application process also needs connection, right? They will reclaim the process from here because you released it. Now others will use it. For example, process count 1000 used is 100, 500 free. This 500 free will be used by anyone connecting to the database, correct? Connection pool. this 100 is coming from the free for now. For instance, consider min is 100, max is 200, and the available is 100 because no one has consumed now. You're now connecting to the database and you're borrowing a connection. Say for instance, the borrowed connection count is 110, available becomes 0 because minimum was 100, so you allocated all 100. And on top of it, 10 more connections also you borrowed, so it becomes 110. Now what's the status of the process count? It becomes free becomes 390 and used becomes 610. I put them in reverse, but just see, used is 610 and free is 390, which is absolutely correct. After borrowed connection timeouts, these two settings, the connection pool status become available becomes 110. Now again, the process count did not change because you're still holding the lock. You're still holding these processes with you. You're not making it available for the other applications. Then it becomes after the inactive timeout, this borrowed connections are all released. Sorry, available connections are all released back to the process count. Say, but we don't release all of them. Minimum connection pool size we retain, and the rest of the 10 on top, whatever we allocated extra, that 10 is released back to the free process count. So if free process from 390 became 400, used is still 600. And if you stop your application altogether, then it will reach the same state of used 500 and free 500. Alright. So now this is what the actual flow diagram is. So I'll be uploading this also to the blog site so you can take a look. Now let's go back to our test routine. So this is what we already saw in them in detail. What is this test routine is all about, and the code also will walk you through. And the next step is to compile the Java code. I already got the Java code copied to my system. We have two putty screens as usual we do. I will just clear my screen. Environment Oracle. So this is the environment setting. Alright, so I already compiled my code, but still I'm going to make it in front of you. See, I have my Java coming from, okay, I have a Java bin downloaded, it seems separately, but it doesn't mean you also don't need to do this. Okay, you can actually use what Oracle supplies you. So Oracle has Oracle Home, JDK, and then bin Java. Here there will be one Java. Okay, I think I have downloaded some version 11 or something, but this version also is good enough for you. For this test routine, I'm using this version anyway. I just checked it. I never knew that I'm using a different Java. Okay, so this is also good enough. I tested this in my other environment, in my real work life. This is working fine. Absolutely, it should ideally work fine. Okay, JDK 8 is fine. And so in the code, UCP Java. So I have 3 versions, but this is our concerned one. Okay, how am I going to compile? Now this is how I'm going to compile this. You need this JDBC 8 and UCP. They are available here in my path. So I am calling them out like this. Okay, you need to download them. Alright, so these errors, warnings, you can ignore. I mentioned it. You should get a Java class path now. Let's look at all the class paths I have. And we are concerned about only UCP timeouts.class. It comes from UCP timeouts.java. It's important that Java creates the same name. I mean, many people don't know Java. I don't have to explain. I think it creates it in the name of this file name, and you also call out this class name here, public class. So this is the name of the Java class that is created here. All right, and then have the shell scripts ready to execute in another screen. So I already got my shell script framed, SQL file framed. They're ready, available here. cpool.sql, cpool.ksh. So this is SQL, this is ksh. Let's run it. Let's make a demo run and see how it behaves, how it shows. This is done, and this is the output file. And you can see it prints the process count. What does all it print? It prints the total process available in the database and used to process count and free process count, and which machine is connected to the database in visualization. There are 55 sessions from this local machine itself, and what are the processes that are connected. Normally I skip background processes, but here somehow I printed it. I think you can exclude background processes. And you can see here This is the candidate program we are looking at. ACH world is the username to which the connection pool will connect, and this is the program name. Alright, this is the what output we are going to get, and every time we make a test routine, the test routine is going to wait 15 minutes, 15 seconds after the start of the test and towards the end of the test. So we will see how the connection pool creates and destroys the connection, and at the same time we will launch this shell script in the database to see how many connections are persisting in the database as well. So you see a connection created in the connection pool, you'll see the same reflecting in the database. You see a connection timed out in the connection pool, you'll see the same getting terminated in the database or getting released. But I mean, only situation where you will see this connection getting reduced is when the inactive timeout comes into play from the available connection. But other times you will see the process count still in use by the same application. And database doesn't know if this is a borrowed connection or a available connection. For database, it is irrespective. It doesn't know. It is only the application it knows it. So if you want to know about that in real, you can enable the JDBC diagonal stability, okay, tracing. Alright, this is how you compile it. Now we see this and have the shell script ready for execution in another script. We saw that. Now we are ready to launch the script. So, and then execute in parallel to step 7 the shell from another screen. When we launch this, it will run through the whole various methods. So we need to get our shell script ready in the other screen to watch it what happening in the database and document your observation. I already got once I executed it, right? So this is what will happen in the connection pool. But I wanted to really document what happens in the database. Are they aligned? Are they aligned as per what our observations are, what we think will be happening in this image file, okay? And we'll say whether the result is success or a failure. And you want to make any notes, you can make a note here, okay? So I'll make this also available for you in the blog. Shall we start? Yes. So let me try executing the Java class, and I'll have the shell script ready. Alright. So I launched it. It's not the time. See, it's running, borrowing, max connection pool reached. Let's execute the shell script. Skip the ready, other one. It's trying to borrow and it's going to time out after some 15 seconds or something like that. See, okay, now it went on to the next test. So this is the next test is for inactive connect timeout. So from available available connection, we're releasing all the connections back to the uh, database itself. So available connection, borrowed connection 5. Okay, so we check this status again. See, I made some changes to the Oracle's universal connection pool Java file so that I can check the DB. Okay, so this is a test routine for time to leave connection timeout, or how long the borrowed connections can stay. Okay, check DB. Actually, this one also should not come. It should be B0, but it's okay. And abandoned connection timeout. You cannot run the SQL query to understand this, how this exactly happens. So we need to prepare a shell script like this and run. And we are waiting for the abandoned connection timer to happen. Yes, check the DB. As the prompt says check DB, you check it. And you also need to check it here. Okay, when it says sleep 15 seconds, that time you will run once time and second time. So this will happen 3 times like this for 3 different settings, and one is connection timeout. For that you can run it only once. So all the operations finished. We already documented it. Now let's go back to DB process count verification. Okay, how many files we have? Right, 1, 2, 3, 4, 5, 6, and 7. We have 7 files created. All right. So we ignore this. This is our first test routine. How many processes in the beginning? You can see there were 63 processes used to process 63. There is one session is from SCH world. Alright, fine. Okay. Mm. Right. So here, this is the beginning of the process. When the capturing of the first test is very difficult because there is no time wait for us because it's in the process itself. It will go happen. Some changes will happen. So only one process was established for this. Result we will say success only. You know, we really difficult to trace this. Difficult to watch this operation because it happens on the fly. It doesn't have any wait time like the rest of them. But for the rest, you will see the difference. So second step, we executed it. 72 you can see here, right? The process count exceeded by 9 more or 10. Actually 62 plus 10, 72. And you can see here the UCP timeout program has a 10 connection established. So in the beginning, the max pool size was reached. Begin 10. And the end, we will see this is the connection statistics. So you can see here, there are 10 connections. Now we need to check the second file, this file. Yes. And connection count came down by 5. See, it's now only 5 process in the end. Total end. In total in the end. So this was expected. You see, there were 10 connections in the beginning. Available connection 5, borrowed connection 5. Borrowed connections were only left alive. There were only 5. So this number matches. In the beginning, there we saw 10 connections were created by the application, which 5 are borrowed, 5 are available. After the inactive timeout, the available connections are released back to the process, the database overall process count. So the available connections become 0. Only borrowed were alive, and so the process count also reduced by 5 more overall process count. So you saw them also reflecting here in the $V process. You did saw, right? The connection $V process reduced from some 72 or something like that to 65, and you can see here, right, 65 and so on. For us, this numbers are reflecting properly fine. $V session. Okay. Next, we will see the next file. 539 and 50. You can see there were 65 processes. There are only 5 processes in the beginning. We'll say in the total begin 5. We will not see this available borrowed connection in the database side. We will only see the total process in the beginning and in the end. But this particular 4550 next one is this one. So you see only one connection, but this was also not expected to be there. It should have been ideally terminated. So I'll put it as 1. Okay, in the real observation, it was also 1. Here we saw. I think was it on the borrowed or in the available? There was one connection in the available. So this one was reflecting fine totally in the end, but in the node section it is success. This is success too in the node section. We saw the connection was there in the connection pool. Maybe the 15-second should have been increased by 16 seconds for in the watch time. Watch time should have been increased a bit more because this connection did not have enough time to time out and reflect to us. So watch time may be less to observe. So why one connection still alive? Instead that should have been terminated. Killed as well. Terminated as well. Next one is abandoned connection timeout. And the abandoned connection timeout you see 03 and 010 and 03. So let's see in the database how it looks. Yes, here you go. You have 10 connections in the beginning. Total beginning 10. total, and ideally what should we see? 3. So let's see if we see 3 connections. This is the last one. 5. Yeah, 3. So all these numbers were reflecting in database fine, and our observations were looking good. Alright, hope you enjoyed this video, and this is it, guys. So we examined the database, we examined the connection pool, we saw both of them working closely, they were all reflecting fine, and our observations were also documented. All the results were successful. So universal connection pool in 19C works perfectly fine. In case you be an Oracle DB or you're a Java developer, you need to watch this video and you get an experience of how this works. In case you want to troubleshoot, start from here. So this is how you start. You start your connection pool, tell the DBA, being a developer, tell them this is the number of connections I have in my pool, and DBA can examine in the database. This is how you need to examine. For a developer, this is how you get exposed to the DB. For a DBA, this is how you will get exposed to the program side, the Java developer side. So you can ask Java developer, okay, how many connections are there in your Java connection pool? All right. They can also enable verbose, diagnosability or verbose in the Java code, such that they get something like that printed in the Java code itself for some time. So in case you go to Oracle for any sort of connection pool issues, right, Oracle will ask you to test this independent module of Oracle Universal Connection Pool with all these timeout settings to prove that it is really an issue with the Oracle product. All right. So there are many things next. If you have a firewall between your application server and the database server, you will see these connections will getting terminated every now and then. Then the firewall setting needs to be tuned. Then comes the TCP alive and other tuning parameters. But for now, you are done. The tests are done and the results are looking good. And we executed our lab today. I'm sure this is a very lengthy video, but I'm sure you would have liked it. If you really like this video, give me a thumbs up button and feel free to share your valuable feedbacks. So if I'm making a mistake, I will also understand. In this video, we also learned how a banking website or a IRCT is working behind the scenes. So hope you, I think you really like this video. Thank you guys. Thanks for staying with me, and we'll meet you in the next video. Bye.